Okay, so for the first problem on here, we're supposed to make a box plot. I'm going to show you two ways to do it. Way number one, you can do this by hand. Or way number two, you can do it on your graphing calculator. Way number one, how you do it by hand is you have to first order the numbers. So we're going to order the numbers from least to greatest. And as I go through, I probably should mark them off so that I don't overpick a number. And there I go. So now I have them in order. Once you have them in order, box plots work by percentiles, and specifically counting up by the quarter percentiles, which are 25%. So we start with 0%, and then we go to 25%, and then we go to 50%, and then we go to 75%, and then we go to 100%. When we do this, our 0th% number was 11. Our 100th percent number is 18 because it's the largest. Our middle number, if we count these, so 1, 2, 3, 4, 5, 6, 7, 8, 9, would be in this middle, or 14. And then we're going to look at the top half and the bottom half to get our 25 and our 75. So in the top half, it would be in between 12. Well, the number in between 12 is 12. And in the top half, it'd be in between 14 and 16, which would just be 15. So these are our numbers for our box plot. So now what we're going to do is we're going to make a number line. Now when you watch me make my number line, I'm going to count by 2s starting at 10, because that will incorporate all of my numbers. I'm not just going to write my numbers down. I'm going to start at 2 and count. And so then at this stage, what we would do is we're going to put a mark where every one of these numbers are. So I'm going to put a mark at 11. I'm going to put a mark at 12. I'm going to put a mark at 14. I'm going to put a mark at 15. And I'm going to put a mark at 18. And then I'm going to draw a box around my quarters, and then just extend the line to the other numbers. And we can see this box plot. So on this box plot, now you're going to look at the shape of it. And you can see the shape is getting pulled to the right because the right side is longer than the left side. So if we were going to talk about the shape, we would say it's skewed to the right, and any time that you have something that is skewed to the right, or you're skewed in any direction, you're going to use the median over the mean. So that is how you would do that problem, by hand. The graphing calculator is actually a little bit quicker. So what we're going to do is we're going to do the exact same problem on our graphing calculator. So we're going to go to Stat, and we're going to make sure all our lists are cleared. So I'm going to clear that list. And I'm going to go over here and I'm going to clear this list. Then I'm going to put all my numbers from here into my graphing calculator. And you're going to notice when I do this, I don't even worry about putting them in order because they don't need to be in order. My calculator will just figure it out. So we've got all our numbers in. The next thing we're going to want to do is go to Stat Plot. And when you go to Stat Plot, so I'll show you how to do that again, we're going to go into the first one, and you have all these different choices. We are going to choose a box plot, because that's the type of graph we are trying to make. And then we are going to hit Graph. Now you're going to notice I can kind of see my box plot, but it's not on the screen. So what we are going to do is we're going to hit Zoom, and then we're going to hit Stat. And then it will show me a much nicer picture of this, which looks very similar to ours. And we can see, oh, we got the right skews. We want to use the median. If you need the exact numbers, if you hit Trace, you can trace over each of these numbers. And we can get them all. And this does a good job of showing us the shape, and so we can draw the shape easily. We're going to probably, for the rest of these, instead of doing them by hand, I'm going to use my graphing calculator, because it's just faster and nicer. Okay, so for the rest of these, we're going to just graph them on our calculator and not do these things by hand because our calculator is a lot faster. So I'm going to go Stat, List, clear out this list, type in all these numbers. And as you can see, it's pretty easy to do this. The biggest thing that you need to do is make sure that you don't type a number in wrong. Then we'll go again to second stat plot. I always make sure this thing is turned on, which it is. I hit graph. It's not in my window, so because it's not in my window, I'm going to zoom, and I'm going to go to zoom stat. And now if we hit the trace button, we can actually see these numbers. And as you can see for this box plot, that it looks like it is skewed. Bless me. Okay, it's skewed left because the tail goes left, which means if it's skewed, we would use the median. Okay, let's try this last one. So again, same kind of thing. I go to stat, I go to edit, I throw this into my list. I go to second stat plot, make sure it's turned on, which it is. Hit graph, it's not in my window, so I go to zoom, stat. And we can see on this one, it's pretty symmetrical. I could see people saying it's a little bit skewed right, but it looks pretty even. So we'll say it's symmetrical. If you wanted to say on the test that that is skewed right with your drawing, I could see it, but it is. The closer it is to the sides being pretty equal, you don't have to have it exactly equal for it to be symmetrical, just pretty equal. So that looks pretty close. Okay, so for these following values, again, I don't want to calculate any of these things by hand. I'm going to use my graphing calculator to calculate all these things. So again, I'm going to go to the top of the list, hit clear list, type in my numbers. Whoa, that would be real big. I'm going to hit stat. And then this time when I hit stat, I'm going to go over to calculate because we don't want to draw a box plot. So we're going to go over to calculate. And I'm going to go to var stat1. I'm going to hit enter. I'm going to hit enter one more time. And this will give me all my data. This first one stands for the mean. So your mean is 5. Let's go back to my calculator. This right here is the sum of all the numbers, so it's not useful. This is the sum of all the numbers squared, so it's not useful. This and these are both your standard deviation. This stands for your sample standard deviation. This SX stands for your sample standard deviation. And your theta x stands for your population standard deviation. For the test, I'll take either. So let's just use our sample one. So we'll go 2.8. And then it will give us all the other numbers beneath here. So our min, obviously our min is easy to find, that's 1. Our quartile 1 is 2. Our median is 5, so this data is symmetric because your mean and your median are the same. Our quartile 3 is 8. Our max is, I think, 9, right? 9, yep. Now we get to these. Your calculator doesn't calculate these, but these are easy to do. Your range is how wide your data set is. So our data set is 8 wide because 1 to 9 is 8. Our IQR is how wide our quartiles are. So 2 to 8 is 6. Our mode is our most occurring numbers, which looks like 2 and 8. Our variance is our standard deviation squared. So we'll put in 2.8 and then we will square it. So 7.84. Okay, so define standard deviation. Standard deviation is the average distance away from the mean or a measure of how spread out your data is. And you can see like 2.8, these things are pretty close together, so the things aren't too far spread away from the mean. Like the biggest distance from the mean is 9 to 5, so that's 4, and that's your biggest distance. So the average distance should be somewhat closer than that, which is 2.8. Your variance. Your variance is the square, your average distance from the mean squared. And that might seem like it's silly to do, but here's the problem with distance for your calculator. Let's say you wanted to find out how far apart 8 and 2 are. Well, if you want to find out how far 8 and 2 are, that is a total of 6 apart. Well, let's say you said, I want to find out how far apart 2 and 8 are. And you were trying to tell someone how you would calculate it. Well, the easiest way to tell someone how you calculate distance is just subtract. But the problem is when you subtract 2 and 8, you get -6, and we don't want negative distances. So how do you fix that? Oh, I square it. So squaring the distances, make sure none of them are negative, and then you can just fix that by square rooting it and getting your standard deviation. Your calculator normally calculates this first, and we'll get this later. So don't overthink that question. Find the percentile of 84. Okay, so for this question right here, percentile means how many people you beat. Or the percent of people you beat. So let's see how many people we beat. We beat 1, 2, 3, 4, 5, 6, 7, 8. So 8 people are beat by the score of 84 out of the total. So 8 over, and the total would be, whoops, I don't know why I need that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Which if you do that, that would be, I think 40%, but we'll double check. Yeah, 0.4 or 40%. Okay, so for this one it says, you decide you want to conduct a survey about the quality of food in a school cafeteria by randomly selecting students as they leave the cafeteria on the way to on lunch on a specific day. Describe the bias that may result and indicate the potential bias. Well, if I only pick one day, the one day is the problem. Because you could have a certain type of lunch on that one day that is more loved or more hated. It will make the data more extreme in the positive or negative, depending on lunch. It would be better to do the survey on multiple days, because then you can start accounting for some of that bias. Okay, we'll try the next problem. Okay, so we need to give something that is positively correlated. That's easy. You just say two things that when one goes up, so does the other. So height and weight, because as someone gets taller, generally they weigh more. Something that's negatively correlated, as one goes up, the other goes down. So maybe temperature and altitude, because the higher you go up, the lower the temperature will get, because outer space is cold. Okay, let's do this residual plot. For the residual plot, again, all you're going to do is throw this data in the calculator. So we'll go to our stats again, we'll go to edit on list. Let's clear out that first list of data. Clear. And then you type in all the numbers. So at this point,
you're either getting really good of typing in the numbers or really sick of typing in the numbers. So when you do this, normally we graph these things, but I don't need to graph this thing because you know what shape it's going to make? A line, because it tells me. So we'll just go over to stat and then go to calculate, and then we want the linear regression, which would be 16.4 x minus, I think it was a minus, 621. Use the model to predict the temperature at 95 degrees. So 16.4 times 95 plus or minus 621. That seems high. Oh, I guess that's the number of cans sold, 937. Okay, that makes sense because this is kind of going up. And then if the temperature is if 95 cans were sold, what's the temperature? So this is kind of backwards. So this would be 95 equals 16.4x minus 621. So we'd have to solve this by first adding the 621 over and then dividing by 16. So that would be 95 plus 621 divided by 16.4, and about 43 cans are sold. So, or not 43 cans are sold, the temperature is about 43 degrees. So we can kind of see that as the temperatures go down, so do the cans. Okay, estimate this correlation coefficient. So here's how I'd go about estimating this correlation coefficient. As you can see, these dots are going down, so we know it's negative. And it's the percent of dots that are close to the line that we draw. So if I was to draw a line, I would probably draw it somewhere in here. So I'd say about, I don't know, 60% of the dots. Maybe that's a little high, maybe that's a little low. But you'll have some options on the test of multiple choice, so just make a good estimation there. For this last question, what you want to do is you want to just compare these box plots and just say some things about them. So one thing that I would say about them is the males average or median weight is higher than the females. And another thing we could say is both the males and the females shapes are symmetrical. And you could also say that the males and the female, or the males data has a larger spread than the females. Anything that you can talk about that you can compare and contrast is better for these things. So you just try to say as much of these things as you can. There's not much else you could say though, right, with it. Like we talked about their centers, we talked about their shapes, we talked about their spreads, and you're done. If you need any help on any of these problems, please let me know.